So in this video we are going to cover all the operators in C language. So this is the interface of Turbo. Just press Alt and Enter to switch to full screen. Now in Turbo, for single line comment we use / operators, and there are total 8 types of operator which we are going to deal with. So first one is, let me use that multi-line comment. So first one is our arithmetic operator, and the second one is relational operator. We also call it as comparison operator. And the third one is logical operator. So in logical operator there are the logic gates and or not. And the fourth one is the bitwise operator. Fifth is the assignment operator, and sixth is the conditional, or also known as ternary operator. And the seventh is the special operators. The last one, increment and decrement. So we will cover each of them one by one. Increment or decrement. So now let's close this comment. So star and close the slash. So these all are the operators, and for the single line comment we use // for multi-line /*. So let's begin with the arithmetic operator first. So let us erase this. So I will give you the brief idea about the syntax of C. First of all, we will do this in Turbo, and when we will learn how this works in this traditional platform of Turbo, we will switch to the VS Code, because in VS Code it is much better as it runs smooth, and many more functions are there which are not in this platform. So this is quite slow, but as a programmer we have to first learn in this only. So the first of all, the header line includes studio.h and conio.h. So conio stand for console input output, and studio for standard input output. So here a hash stands for preprocessor. So this hash is the preprocessor, and studio for standard input output. Input output header, .h for .header. So this basically is used for printing the output and giving the input, like printf and scanf. Similarly, conio.h is for console input output. This uses specific special console functions, so keyboard functions. It's console input output header. Okay, so now let's begin with the arithmetic operator. So these are plus, minus, multiply, divide, that is floor division, that is modulus. So basic these are. Now let's begin the syntax. We have written 2 header line. Now we have to write void main function, then give a curly bracket and write the variable name. Suppose I took A and B and C. Now I am using the predefined program, means I am giving the value at this level only at the time of programming. Suppose I gave A's value as 10 and B's value as 100. Now I want to store the sum of A and B in the variable C. So A, I'm using plus operator, this one is plus, and Turbo is case sensitive, so we have to be careful about the letters. It should be lowercase if we have written in lowercase. Plus operator B. So what will this do? C will store the value of 10 plus 100, so it will be 110. Now I will just print it. So for this we have to write printf sum of A and B is, the sum is in the integer form, so it will be %d, that is a specifier, comma. So where the value of sum is being stored in the variable C, so I have to write C here. Now just completing my syntax by writing .ch and just closing the curly bracket. So the output should be 110. Let's run it. So there are 2 errors. In .ch I have to use a terminator over here. Now let's run. Sum of A and B is 100. Now suppose I want that instead of A and B it should be discrete sum of 100 and 10 is 110. So for that I will just change this printf statement. Sum of %d and %d is %d, comma, first %d it should be displayed as 10, the first value. So you have to take care of the sequence of the variable which you will write here. Suppose if I write A, comma B, so sum of 10 and 100 will be shown here. If I write b comma a, then sum of 100 and 10 will be displayed here. So this is how it works. So a comma b comma c. Now it should be displayed as sum of 10 and 100 is 110. So just press Ctrl F9. So the previous output is also displayed here. So for that we have to just clear the previous output. So for that we have to use clear screen function. So here I will just write clear screen. So sum of 10 and 100 is 110. We have to do the same thing for minus operation. So here I'm writing minus. So this is where we get stuck in turbo, because it doesn't remove the exact element. This is a, you can say, a drawback of turbo or a glitch like thing. So a minus b, 10 minus 100, it should be a negative value. I will just change this. I will just display the answer C. So it should be minus 90. Now if I want 100 minus 10, I will just do this b minus a. So it's 90. Similarly for the multiplication, if I do a multiply b, I will get 1000. Similarly for division, a slash b means 10 divided by 100. Or I should do b slash a. So it is giving 10, means it is just dividing 100 by 10. So on dividing 100 by 10, we are getting 10 itself. Now if I change the numbers, if I write here 5 instead of 10, so 100 divided by 5, it should be 20. So this is the single slash, it is used for division. So it just displays the quotient value. Now for the float division, that is b double slash a. So double slash doesn't work here. B modulus a. This will return the remainder value. It means 100 divided by 5. So it should return the remainder, means on dividing 100 by 5, we got the remainder 0. So it should be 0. See. So this is all about the arithmetic operators. Now all the programs were predefined. We were inputting the values of the variable a and b. Now if we want the user to input the value according to them, so for that we have to make a user defined program. For that we have to use scanf function. So I'm erasing it. I will write clear screen here so that previous output is not displayed. Now I will write printf. I will display a message which will ask the user to please enter your first number. So enter first number. So this message will be displayed to the user so that the user will enter the number. Now after the user enters the number, it will be stored. So we will use scanf. Scanf, integer values we are taking, so we have to use the specifier %d. If we were taking decimal value, that is float value, here we have to write float instead of int, and at the place of specifier we have to write %f small f for the float. I will give all the specifier details, comma, the variable at which this first number will be stored. See here I took a, b and c, 3 variables. So suppose I want to store the first number at the variable a, so I will use a at a. So this is at is a special operator which is used to store the value at this variable. Now don't forget the terminator. Now again I have to ask the user to enter another number, so enter second number. In the same way, scanf will be used to store the value. Now this time we are storing at b. Now at c we are storing the values of addition of a and b. Now just print the output, printf sum of at a sorry %d and %d is %d. So first %d is at a, b comma c. Now complete the syntax by get ch and just close the bracket. So in this program, first the output will ask the user to enter first number. It will be stored at a variable, and again for the b, and then in the c the addition value will be stored and that will be printed. Sum of whatever number is will be calculated. One error is there. So here I haven't written printf. It should be printf enter second number. Now let's run. So see, it is asking for first number. Suppose I entered 300. Now for second I entered 20. So the sum of 320 is 320. Look, so this is how we make a user defined program. Now I was talking about the specifiers. Let me use a multi-line comment. So first specifier is like int. For int, if we want to take the input or show the output in the integer form, non-decimal value, so we have to use the specifier as %d small d. For the float, that is for decimal, we use %f. For character value, we use %c. For the string value, string is whatever inside the quotes, %s. For long integer value, we use %ld. For double value, we use %lf. And for long double value, we use so capital L, uppercase L, and F small. So this is all about the specifier. All these are the specifiers. Now let's jump to the another operator, that was our relational. So in turbo, control C, control V doesn't work. For this, it has a different shortcut key that I will be informing you. Operator is relational operator. So these are greater than, smaller than, greater than, equal to, smaller than, equal to. Then this is equality. It will check equal to or not, and not equal to, exclamatory equal to. So for if the condition will be true on comparing them, so if the value is true, condition is true, it should display 1, and if it is false, it should display 0. So it gives the output in Boolean form. Now suppose I take two integers a and b. It just use clear screen. Now I am giving the value of a as 100 and b as 500. Now I want to print whether a is greater than b or not. A is greater than b or not. See, 0 is coming because it is checking as a means 100 is greater than 500. So this is false, so that's why it is showing 0. Now if I change the values, I gave here 5000. Now okay, let it be like this. I gave here 1000. Now 1000 is greater than 500, so it should display 1, that is true. So let's do for other operators also. Printf, I'm using /n so that the next output will be in the new line, another below next line. So a smaller than b is %d. So it will check whether a is smaller than b or not. Now again, so if I don't want to write again and again, so copy paste doesn't work here. So for copying, we can use control plus insert, and for paste we can use shift plus insert. /n a greater than or equal to b is %d. Can print them. So look here, it will check whether a is greater than b or not, this one. So a stores the value 10 is greater than 5 or not. So this is true. So the output should be 1 for true. And similarly here, a is smaller than b means 10 is smaller than 5. So this is false. So it should display 0 for false. Similarly, a is more than or equal to, or you can say greater than or equal to b means 10 is either greater than 5, or you can say 10 is equal to 5. So if any of the condition is true, it should display true. So here 10 is greater than 5, it is true. So it should be 1. Similarly here, a is smaller than or equal to b means 10 should be smaller than 5, or it should be equal to 5. So this condition is false, and this is also false. So it should display 0 for false. Now double equal to will check the equality, means a should be equal to the value of b means 10 should be equal to 5, which is not true. So it should be false. For false it is 0. Now here a should not be equal to b. This exclamatory equal to is for not equal to, means a is not equal to 10 is not equal to 5, which is true. So it should be 1. So our output should be 1 0 1 0 0 1. So 1 0 1 0 0 1. This is all about the relational, which is used to compare the values. Now moving to the next, we have our logical operator. So logical operator are 3, and, or, and not. So it's logical. These are and. The symbol of and is like this. Then or. For or it's like vertical bar, double vertical bar, and for not it is exclamatory. Now again I am taking two variable a and b. Let us take one more c. Now let's clear the previous output by clear screen, and I am taking the input of a as 20 predefined and b as 5 and c as 2. Now I will print a is greater than b and b is also greater than c. Is %d. %d, why %d? Because logical, like relational, logical 2 gives output in the boolean, that is 0 and 1 form. So these are integers, so I have to use the specify %d. Now I'm using and operator, and b is also greater than c. So what it will does, it will check whether value of a is greater than b or not, and along that value of b should also be greater than c. If both the conditions are true, then only the output will be true. So this is how and works. For and, and I'm writing it down. For and, the symbol is this. Both the conditions should be true. So here it will check whether 20 is greater. It will check whether 20 is greater than 5 or not, and along with that, and 5 should also be greater than 2. So these both conditions are true, so it should be 1. The output should be 1 for true. Now let's check by running it. Just write get ch. See, both the conditions are true, so it is showing 1. Now let's do it for another operator, that is or operator. So printf, again I am giving two conditions. It is b should be greater than c, or this is or symbol, vertical bars, that is 5 symbol, and c should be smaller than b, and the output will be boolean form, so it should be specify %d. So b should be greater than c, or c should be smaller than b. Now how will this work? It will check whether value of b5 is greater than 2. So this is true, or 2 is smaller than 5. This is also true. So it is true, so it should show 1. So for or operation, or operator, what it does, the symbol is this. Any one of the conditions should be true. It is not necessary that both of the conditions should be true, as it is in the and op case. In or, only one condition can be true and the output will be 1. Any one of the condition, better to say, any one of the condition should be true. Now let us check it. See, again for next also it is showing 1. Here I should write /n so that the output is displayed in the next line. Suppose I change the numbers. Suppose I change this only. Instead of c smaller than b, I am writing a smaller than b. So now look, this will check for b greater than c, means 5 should be greater than 2. This is true. Or it will check for 20 is smaller than 5. So this is false. This first condition, 5 is greater than 2, is true, and 20 smaller than 5, second condition is false. So 1 is true, 1 is false. It should display 1 again because one of the condition is true. So let's check. So look, again 1. Now the last operator is not operator. And or. So unlike these two, not operator requires only one
condition to work on. Like and in and or we have to give two conditions, but for not only one is needed. So not I'm printing a greater than b. So I will use not a greater than b. So what it will do, it will just reverse the output. Means if the condition is true, it will print false, and if it is false, it will print true. So what not does, opposite value or opposite prints opposite of the condition. So here, what's the value of 8? 20 is greater than 5. So this is exactly true. So what if we will be using not? It will print 0, false. So we will get 1, 1, 0. So we are getting 1, 1 and 0. So this is all about logical. Now let's move on to another operator, that is bitwise operator. All these operators we will also see in C++. So the next is bitwise operator. So we have bitwise XOR, and its symbol is like a cap symbol, that is this one, above 6. And after that we have left shift. This is our left shift. And then we have right shift. And we have bitwise not operator. So it is represented by a tilde symbol, that is just before 1 in the your keyboard key. So it is tilde. This is for not. In logical for not we were using exclamatory mark, and in bitwise not we will be using tilde. Now we have bitwise and operator, that is single and. In logical we were using double and. This is and. And we have bitwise or. So for bitwise or, the symbol is that vertical bar. So these are the 6 bitwise operators. Now if I write void main int a comma b comma c, I'm inputting a as 5, b as 6. This bitwise operator. So I take two variable a 5 and b 6. So I'm printing 5 and 6. 6. I'm getting 4. So I'm printing 5 and 6. I'm getting 4. So this bitwise operators works on the bit level or operates on the bit level. So let's check what's the output. 4, 7, minus 6, 2, 10 and 3. So this is a means 5 or 6. We are getting 7. And here on using not 5 we are getting minus 6. And on here a is 5, right shift 1 we are getting 10. And here 5, left shift 1 we are getting 3. And on here on doing 5 bitwise XOR 6 we are getting so here on doing 5 right shift 1 we are getting 2, 5 left shift 1 we are getting 10, and on doing 5 XOR 6 we are getting 3. So how is this working? Let's find it out. Bitwise operator. So this were and, or, not, right shift, left shift and XOR. So now let's do theoretically for understanding it. So first example was for AND 5 and 6. So for this we have to write the binary of 5, that is 0101, and put 4 zeros over here to make it 8-bit. And for 6 we have the binary as 0110. Now we have to perform AND operation, this one AND. So in AND, so if I take A and B, two inputs, and 0011 0101. Now for 0 and 0 I will get 0, 010 100, and for 11 I will get 1. So AND operator results in 1 only if both the inputs are 1. So here I have 1 and 0, so it should be 0 only. 1 0 0, 1 and 1 will be 1, 0 and 0 zeros again. So this will be my final output. Now by the power method I will find the decimal of it. So this is the binary of 4. That is why we are getting 4 on doing 5 and 6. You can do it as 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So this will be 1 into 0 1, 2 into 0 2, 2 is to 2, 4 into 1, that is 4. So the next one was 5 or 6. So in the case of OR, if I take A and B, 0 0 1 1, 0 1 0 1. So for OR 0 and 0 I will get 0, 0 1 1, 1 0 1, and 1 1 1. At least one input should be true. So here both the inputs are false, so I am getting false. Here B's input is 1, I am getting 1. 1 here, 1, 1 here, and here also 1. So at least one condition should be true, so we will get 1. So now let's perform on this. Here the binary of 5 is 0101, and for 6 it is 0110. Now perform OR. So 1 or 0 will be 1. 0 and 1, 1. 0 or 1, 1. 1 or 1 is also 1. 0 or 0 is 0. Rest all zeros. So this is nothing but 7. Let us check here. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So this will be 1 is to 1, 1. 2 raised to power 1, that is 2 into 1 will be 2. 2 raised to power 2 will be 4 into 1 will be 4. So 4 plus 2, 6 plus 1, 7. So on doing this we are getting 7. So this is how the output is coming. Now next was not 5. So not 5. This is just inversing the value, means for 1 it will be 0 and for 0 it will be 1. So the binary of 5 is 101. So it will turn this 0 into 1, 1, 1, 1, 1, and this 1 into 0. It will just reverse. So this new number is nothing but -6. Or you can also apply the short trick, that is, if something is -n, so its formula is -n plus 1. -n plus 1. So we have minus, that is not 5. So it is -5 plus 1. So that is -6. So that is why if we do any number like not 10, we will get -11. Now next was right shift and left shift. So we have 5 right shift 1, because this is like this, it is moving toward the right side. So 5 right shift 1. So write the binary of 5, that is 0101, and here zeros 1 2 3 4 5 6 7 8. Now what we have to do, we have to just shift the bits towards the right side. So this will be shifted towards the right side, and here 1 is there, so we will leave this one place and we will shift this 0 to here, and this to here, this to here, this to here, this here, this here, and this here. So it will be 0 0 0 0 0 1 0. So all these got shifted and this will be terminated, and here we will put 1 0. So we are getting this. So this is 2, because it's 2 raised to power 0 and 2 raised to power 1, that is 0. This is be 2, this will be 2, so we are getting 2. Let's take one more example. Now let's take one more example of 16 right shift 3. Okay, so what we have to do, we have to write the binary of 16. So binary of 16 is 0 0 and 0. Okay, now we will make it 8-bit by writing 3 zeros over here. Now what we have to do here, 3 is written and a right shift symbol is there, so we will shift the digits towards the right side by leaving 3 spaces, this and this 3 bits we will leave here, and we will shift these numbers over here. So what we will be getting, that is 0 0 0 1 0, and these zeros will be terminated permanently. So we will put zeros here also. So this is our output. So this is again 2, that's why we will be getting 2 on doing 16 right shift 3. So this is how the bits are shifted through the bitwise shifting operator. So there is also a short trick for it, like on doing this we got 2, and on doing 5 right shift 1 we got 2 again. So there is a trick for it, for the right shift operator. If it is 16 right shift 3, just divide 16 by 2, you will get 8, and again divided by 2 you will get 4, and again divided by 2 you will get 2. So this is my answer. Now same for 5 right shift 1, just divide 5 by 2, you will be getting something like 2.5. so this 2 before decimal floor value will be the answer. So I have shown how the computer computes this operator, shift the bits, and this is how the short trick works if you want the theoretical answer. Now next is our left shift operator. So for that we have written 5 right shift 1. So this 5 left shift, because it is shifting towards the left side. So this also works very similar to what I explained in the right shift. So just write the binary of 5, that is 1 0 1 1 more 0. Now this time the symbol is for right shift, so you have to shift the digits towards the right side, this side. And how many digits we have to, how many bits we have to leave? 1 bit, because 1 is written here. So from the right side leave 1 bit space, and then keep on shifting the digits like this. So we will be getting 1 0 1 0 0 0 and 0, and this 0 will be terminated, and here in this blank space write 0. So this is our answer. So this is again 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So this is 0, this is 2, and this one is again 0, and this one is 8. So 8 plus 2 is 10. So we are getting 10. And again one short trick is there for this. For the left shift, So for this, the short trick is write the number here. The 5 is written, so 5 into 2. We have to write the binary 2, and this, the number which shows how much bits we have to leave and shift the digit. This is the number 1. So write this number to the power of 2. So 5 into 2 raised to power 1 will be 10. So this is the short trick. We are getting 10. Suppose I'm doing 6 left shift 2. So it will be like 6 into 2 raised to power. Here 2 is only there, so 2. So it will be 6 into 4. 6 4 times 24. Next one is the bitwise XOR. So we took A cap B, and the value of A was 5 XOR 6. So how does XOR work? If I'm taking A and B and I'm doing 0 0 1 1 0 1 0 1. So for XOR, output will be 1 if both the inputs are different. So in this combination 0 and 1, inputs are different, so it will be 1 and also 1. And in the 0 and 0, 1 and 1, both the inputs are same, so it will be 0. So this is how it works. Now let's perform for 5 or 5 cap 6. So the binary of 5 is 0 1 0 1, and 6 now 1 XOR 0 will be 1, 1 0 XOR 1 will be 1, 1 XOR 1 0, all these zeros. So it is 3, because it is 2 raised to power 1 0, 2 raised to power 1, this is 2 raised to power 2, so this is 1 and this is 2 and this is 4. So 2 plus 1, 1 into 1 will be 1, 2 into 1 2, and this into 0 will be 0, so 2 plus 1 3. So this is how XOR works, very simple. So this is all about the bitwise. Next is our assignment operator. Next operator is the assignment operator. So this is used to assign values to the variable. These are like plus equal to, minus equal to, product equal to, divide equal to, and modulus equal to. So how this work? Let's look. See, if I take input A as 20, and now I do A plus equal to 10. So this is my assignment operator. This is also my assignment operator. A equal to 20, equal to is assigning the value of A as 20. And here I am writing plus and minus operator together. So this is termed as compound operator. And they have to be written together. No space between them. So between plus and equal to, there should be no space. So how does this work? A plus equal to 10 means A equal to A plus 10. Means this A is storing the previous value of A, and in that it is adding 10. Means 20 plus 10. 20 plus 10. So it should be displaying 30. So let us printf %d A. I haven't put here bracket. Now 30 is being printed. Now similarly, let's do each of them. So this will work as A equal to previous value of A. This value will be taken 30. So 30 minus 10, that is 20. Just print it. Now again, if I do A product equal to 10, or let's do 5, I will be getting as A equal to the previous value of A, that is 20, will be updated as 20 into 5. 20 multiplied by 5. So the result will be 100 will be the output. Again, A slash equal to 10, or let's do it as 2. So this will update the value of A as previous value of A was this 100. So 100 slash 2, the answer is 50. So we will be getting 50 on printing this. I should also write slash n. Here again slash n. Now A modulus equals to, let's do 10. So this will update the value of A, that is 50 modulus 10. So the remainder will be returned. So on dividing 50 by 10, we are getting remainder as 0. Zeros will be displayed. Now printf. So on dividing 50 by 10, we will be getting the remainder as 0. So we will get output 0 on printing it. So let's just print. So 30, 20, 100, 50 and 0. 30, 20, 100, 50 and 0. This is the assignment operator, quite easy. Now next is conditional operator, or we also call it as ternary operator. So ternary or conditional. Suppose I want to make a program which shows that the entered year is leap year or not. So in this program I will be using the conditional operator. These are question mark and colon. Suppose I am taking a year, int year, and I am giving year as 2000. So I have to check here if year, on dividing year by 4, if I'm getting 0. So one conditional question mark where we have to write. If this is true, then we have to print f, it's a leap year. And if the condition is not true, so we will be using this colon and we will printf not a leap year, not a leap year. So it's a leap year if I change this number as year as 2001. So we all know it was not a leap year as it is not divisible by 4. So we are getting not a leap year. So this is how conditional operator works. Here this modulus will check the remainder. If it is true, 0 is coming, this statement will be printed. And if it is not, so then we will break this by this colon and this will be printed. Next is our special operator. This is the last one. So in special operator we have address of operator, that is this at address of operator. This stores the memory address. Next we have another one, that is pointer. So this asterisk is the pointer. Next is size of. This tells the byte size. Now let's do it practically, writing the header line. Pointer B. I'm storing the address of A at B. So B equal to address of A, that is at A. Now I'm printing size of int. Value of B is %d B. Now printf value of A is Send D pointer B. Value of B is %D. So pointer B again. So here we will be getting the size of the integer, that is 10. That is 2 bits, so we will be getting 2. Value of B. So B. So add A. 2 minus 12, 10 and 10. Here size of int is 10 is 2 bits, so here 2 is coming. And here we are getting minus 10. Or minus 12, I guess. This is the address value. That is minus 10. And this pointer is just storing the memory address of A. So we're getting 10 because, so this is how it works. Increment operator. So it just increments the value by 1. Means if my variable contains a number, suppose 10, so when I will use increment, it will be updated to 11, 10 plus 1. Similarly, decrement just decreases the value by 1 digit. So decrement of 10 will be 9. If I input A, I give the value of A as 40. So first one is A plus plus. So this is my increment operator. And this is this double plus symbol is increment, and it is used after the variable. So it is post increment. Now what will this do if I will print F now this? It will just update the value as 40 plus 1. It will just increment the variable A with 1 step. So it will be 41. You can use pre-increment also. In this we have to write the increment operator before the variable. This also works the same way, so we can use it either way. This is pre-increment. Now if I will print this, /n is required. This will also update the value, but this time this value will be updated. If I want this value to be updated, I have to comment these. So right now I am not doing anything. It will just update 41 by 1. So it will be 42. So let's check this. So we should get 41 and 42. Here I haven't used terminator. Now, so 41 and 42. Similarly, decrement operator. So first one is A minus minus, that is my, I'm using this double minus symbol, that is my decrement. It will decrement the value by 1. So it is being written after the variable A, so it is post decrement. So you can use it either way as per your will. So now if I will print this, how will it work? It will decrement the value of A, that is 42 minus 1. So it will be 41 again. Similarly, you can use it as a pre-decrement. So we will write minus minus first and then variable. So this is my pre-decrement. So it will be printing as 41 minus 1, that is 40 again. So this will work as 41 minus 1, that is 40. So this is how it works. If I want that only I want to decrement the original value of 40, suppose this one, so I will just comment this out. So now this will decrement the original value of A, that is 40 minus 1. So I will be getting 39. So this is about increment and decrement.